Hello everyone, this is Dharambi sir here. So today we are going to start chapter 13 of grade 12 maths, which is probability. And the topic of this video is conditional probability. So let's start. Now first let me tell you what is the meaning of conditional probability. So if E and F are two events associated with the same sample space of any random experiment, then the conditional probability of E under the condition that the event F has already occurred, written as PE by F, is given by PE by F equals to PE intersection F upon PF, provided that PF is not equal to 0. Now this is the formula and definition. Now coming to the meaning. Suppose we have to find the probability of an event, provided that some event has already occurred, that the event F has already occurred. Under that condition we are going to find the probability of some other event E. Then it is said to be the conditional probability of E over F. Clear? So pause and note down the definition. Now few properties of conditional probability. So let E and F be events associated with the sample space S of an experiment, then P S by F is equal to Pf by F, which will be equal to 1. That the conditional probability of sample space S over any event F will be equal to conditional probability of any event F over F, which will be equal to 1. Second is probability of A union B over F. A union B over F will be equal to P A by F plus P B by F minus P A intersection B by F. So simply we have used the formula where A and B are any two events associated with S. Third is P E dash over F, it will be equal to P, it will equal to 1 minus P E over F. Clear? So pause and note down these important points. So let's start exercise 13.1. And the question 1 is, given that E and F are events such that PE is equal to 0.6, PF equals to 0.3 and PE intersection F equals to 0.2. Then find PE by F and PF by E. So we have PE is equal to 0.6, PF equals to 0.3 and P intersection F equals to 0.2. So PE by F will be equal to, using the formula, PE intersection F upon PF. So putting the values we get 0.2 upon 0.3, which is equal to 2 by 3. And PF by E is equal to PF intersection E upon PE, which is equal to 0.2 upon 0.6. Simplifying we get 1 upon 3. Clear? So pause and note down the solution. Moving to question 3. If PA is equal to 0.8, PB equals to 0.5 and PB by A equals to 0.4, then find PA intersection B, PA by B and PA union B. Now we have PA is equal to 0.8, PB equals to 0.5 and PB by A equals to 0.4. Now PB by A equals to 0.4. So using the formula for PB by A, we get PB intersection A upon PA equals to 0.4. So putting the values, we get PA intersection B upon 0.8 equals 0.4. So PA intersection B will be equal to 0.8 multiplied by 0.2, which is equal to 0.32. Now second is PA by B. So using the formula, we get PA by B equals to PA intersection B upon PB. So putting the values of PA intersection B and PB, we get 0.32 upon 0.5. So simplifying, PA by B equals to 0.64. Third is PA union B. Now PA union B is equal to this one, PA plus PB minus PA intersection B, the formula that we learned in grade 11th. 0.8 plus 0.5 minus 0.32, which is equal to 0.98. Clear? So pause and note down the solution. Moving to question 5. If PA is equal to 6 upon 11, PB is 5 by 11 and PA union B equals to 7 by 11, then find PA intersection B, PA by B and PB by A. So we have PA union B equals to 7 upon 11. So using the formula for PA union B, which is equal to PA plus PB minus PA intersection B. So putting the values, we get 6 upon 11 plus 5.11 minus PA intersection B equals to 7 upon 11, and simplifying, PA intersection B is equal to 1 minus 7 upon 11, that is 4 upon 11. Next is PA by B. So using the formula, PA by B equals to PA intersection B upon PB. So putting the values, we get 4 upon 11 upon 5 by 11, that is 4 by 5. Third, we have to find PB by A. So using the formula, we get PA by B equals to B by A equals to PA intersection B upon PA. So putting the values, we get 4 upon 11 divided by 6 upon 11, that is 2 upon 3. Clear? So pause and note down the solution. Next we have question 6. Determine PE by F in exercise 6 to 9. So question 6 is, a coin is tossed 3 times, where 3 parts are there. I am solving second part for you. There is E at least 2 heads and F at most 2 heads. So E at least 2 heads, we have tossed the coin 3 times. So E will be equal to HHH, HHT, HTH and THH. So number of elements in E is equal to 4. And F at most 2 heads. So finding F at most 2 head. So F will be equal to HHT, HTH, THH, STT, TST, TTH and TTT. So NF equals to 7. So finding E intersection F, we get HST, STH, THH. So number of elements in E intersection F equals to 3. So hence probability of E is equal to 4 by 8, that is 1 by 2, probability of equals 7 by 8, and probability of E intersection F equals to 3 by 8. So PE by F will be equal to PE intersection F upon PF, that is 3 by 8 divided by 7 by 8, which is equal to 7 upon 8. Clear? So pause and note down the solution. Question 8. A die is thrown 3 times. E4 appears on the third toss and F6 and 5 appears respectively on the first 2 tosses. So the sample space for the random experiment that a die is thrown 3 times will contain 6 cube. We know this formula. 216, that is number of elements in the sample space, will be equal to 216. Now E4 appears on the third toss. So the sample space for the event E is this one. You can see this is the sample space for the event E, and F equals to 6 and 5 appear respectively on the first 2 tosses. So this is why the sample space for F. So PF equals to 6 upon 2 and 6. PE intersection F equals to 1 upon 2 and 6. So PE by F equals to PE intersection F upon PF, that is 1 upon 216 upon 6 upon 216, that is 1 upon 6. Clear? So pause and note down the solution. Next is question 9. Mother, father, son line up at random for a family picture. E, son on one end and F, father in the middle. So let M, F and S denote the mother, father and son. The sample space will be S equals to MFS, MSF, FMS, FSM, SMF and SFM. So number of elements in S equals to 6. So E on one end and F, so E is equal to MFS, FMS, SMF and SFM. So any first, probability of E is equal to 4 by 6. F is the father in middle, so F equals to what? M, Fs and SFM. So number of elements in F is 2, so PF is 2 by 6. So E intersection F is equal to MFS and SFM. So probability of PE intersection F is 2 by 6. So probability of E by F is equal to PE intersection F upon PF, which will give 2 by 6 upon 2 by 6, that is 1. Clear? So pause and note down the solution. Moving to question 10. Black and red dice are rolled. Find the conditional probability of obtaining a sum greater than 9 given that the black die resulted in 5. And B is find the conditional probability of obtaining the sum 8 given that the red die resulted in number less than 4. So let X denote the outcome on black and Y denote the outcome on red dice. So the sample space is XY such that XY belongs to 1, 2, 3, 4, 5, 6. Number of elements, since 2 dice are rolled, so number of elements in S will be equals to 6 by 6 into 36. So E is the sum that X plus Y is greater than 9. So X plus Y can be 10, 11 and 12. So E becomes 6, 4, 6, 5, 6, 6, 5, 5, 5, 6, 4, 6. and F that black die resulted in Y in a 5. So F will be 5 1, 5 2, 5 3, 5 4, 5 5, 5 6. So NF equals to 6. So probability of F is 6 by 36. And E intersection F will have 5 5 and 5 6. So probability of E intersection F equals to 2 by 36. Therefore, probability of E by F equals to probability of E intersection F upon PF, that is 2 upon 36 divided by 6 upon 36, which is 1 upon 3. Clear? Pause and note down the solution. Question 12. Assume that each born child is equally likely to be a boy or a girl. If a family has two children, what is the conditional probability that both are girls, given that the youngest is a girl and at least one is a girl? Now let the first, that is the elder child, be denoted by capital, and the second, that is the smaller child, is younger child, is denoted by small letter. So the sample space is BB, BG, GB or GG. So number of elements in S is 4. So E is that both children are girls. So E becomes the sample space GG. So number of elements in E equals to 1. So PE is 1 by 4. So coming to the first case, let F be the event that the youngest, that is second child, is a girl. So F is BG and GG. So NF equals to 2. So probability of F is 2 by 4. So E intersection F is what? GG. So number of elements in E intersection F is 1. So probability of E intersection F is 1 by 4. So probability of E by F will be equal to P intersection F upon PF, that is 1 by 4 divided by 2 by 4, which is equal to 1 by 2. And the second part, let F at least one girl is a child. So F is BB, GB and GG. So NF equals to 3. So PF is 3 by 4. So E intersection F is again GG. So probability of E intersection F is 1 by 4. So probability of E intersection F, E by F equals to P intersection F upon PF. So 1 by 4 divided by 3 by 4, that is 1 by 3. Clear? So pause and note down the solution. Moving to question 13. An instructor has a question bank consisting of 300 easy true-false questions, 200 difficult true-false questions, 500 easy multiple choice questions, and 400 difficult multiple choice questions. If a question is selected at random from the question bank, what is the probability that it will be an easy question given that it is a multiple choice question? Now the total number of questions is 1400. So NS is 1400. Let E, the selected question, is easy, and F, selected question, is a MCQ. So E intersection F will be what? Selected question is an easy multiple choice question. So number of elements in E intersection is 5. So NF is 500 plus 400 is 900. So PE intersection F equals to what? Probability of E intersection F upon NS, that is 500 upon 1400. So PF is NF upon F is 900 upon 1400. So the required probability PE by F equals to PE intersection F upon PF, which will be equal to 500 upon 1400 divided by 900 upon 1400, that is equal to 5 by 9. Clear? So pause and note down the solution. 15. Consider the experiment of throwing a die. If a multiple of 3 comes up, throw the die again, and if any other number comes, toss a coin. Find the conditional probability of the event the coin shows a tail, given that at least one die shows a 3. So the sample space is 1H1T, 2H2T, 3-1, 3-2, 3-3, 3-4, 3-5, 3-6, 4H4T, 5H5T, then 6-1, 6-2, 6-3, 6-4, 6-5, 6-6. So number of elements in S is 20. Now let E, the coin, shows a tail. So E is 1T, 2T, 4T, 5T. So NE is 4. NF, at least one die shows a 3. So PF is 3-1, 3-2, 3-3, 3-4, 3-5, 3-6, 6-3. So NF is 7. So E intersection F is 5. So number of elements in intersection F is 5. So probability of E intersection F will be equal to N E intersection F upon NS, that is 0.20, so 0. So the required probability, that is P E by F, equals to P E intersection upon PF, so 0.PF, that is 0. Clear? So pause and note down the solution. With this, we end exercise 13.1. So solve the remaining sums and don't forget to solve the examples given before the exercise. Thank you and all the best.